Hello students, in the last video we discussed related to the equation of simple harmonic motion and displacement, velocity and acceleration, and where those are maximum and where those are minimum, that all we discussed. And now in this video we will discuss related to what are the graphs are taking displacement time, velocity time, displacement acceleration, velocity acceleration, and that all. So first of all we will take the graphical expressions of the displacement time graph. First we are taking displacement versus time. Displacement versus time. Actually time is nothing but we can take a time period like. So here I am considering the equation y is equal to a sin omega t. You can also consider x equal to a cos omega t. No problem. So first I am taking the situation. The particle starts from origin. At origin means at mean position which it starts, I am taking time on x-axis and displacement on y-axis. Now the particle starts from mean position and it is going like this maximum value. This is extreme position. At extreme position we know that displacement is maximum. How much? A. And again which is comes to the mean position. At mean position what happened? Mean position again displacement 0, and it is moving to the another extreme position with the maximum amplitude, maximum displacement, and again extreme or mean position. If you are taking it as mean position, displacement 0. What is the displacement? 0. And extreme position, maximum amplitude. Mean position, displacement 0. Amplitude maximum, but in which direction? In opposite direction. That's we are taking as minus a, and then 0, and then 0. This is simply that. And you can take total time how much up to here? T. And for half it is taking t by 2. And for this it is taking t by 4. For this it is taking 3t by 4. 3t by 4. 3t by 4. And here only I am giving that the displacement of the particle for when which is moving from extreme to extreme, mean to extreme, displacement is a. Mean to extreme displacement is a. And extreme to mean displacement 0. Mean to mean displacement 0, and mean to extreme displacement again minus a, and mean to mean means for the displacement of the particle one oscillation is 0. Displacement of the particle for one oscillation, how much displacement is 0. What about the distance for one oscillation? Distance, can you say how much? Yes, distance is 4a. Distance is 4a because distance is independent on direction. The displacement of the particle for one oscillation is 0 and the distance of the particle is 4a. The distance of the particle is 4a. This is for y is equal to a sin omega t. In case if you are taking x equal to a sin omega t, a cos omega t, then what will happen? If you are taking cos function, what happen? Nothing change. If you are taking cos function, what is happening? It is starts from extreme position. It is starts from extreme because cos 0, 1 maximum value. So the difference you can observe. This is extreme position. Particle starts from extreme. At extreme position maximum amplitude. And then mean position minimum displacement 0. And then comes to like this. And then goes like this. So similar whatever you are considering, nothing different, x or y graph, whatever you can take, but same. But you can observe, if you are taking sine, how you are getting, if you are taking cos, how you are getting. If you are taking sine, you will get like this. If you are taking cos, like this. This time is going to be t by 2, this time t by 4, this time 3t by 4, and this time is t, this time is t. T by 4, t by 2, 3t by 4, t. Like that we can able to take for x equal to a cos omega t. Again you can take it is as a plus a, and this is as a minus a. That's all. That's all. Which is a nothing difference. Anyone you can able to take. Anyone you can able to take. Next, I'm taking velocity time graph. This is displacement time graph. Next, you can take velocity time graph. Velocity time graph. So what it represents velocity time graph? See here, very simple. Which equation we are taking? Y is equal to a sin omega t. So that's why here velocity what we have to take? A omega cos omega t. A omega cos omega t. So let's see here. What we are considering here? Mean position. At mean position, what about the velocity? Maximum. How much? A omega. So the graph will comes like this. Here what is the value? A omega. It is extreme position. See here. Mean, first mean, extreme, mean, extreme, mean, extreme, mean, extreme, mean. Means you are taking similar to this. Similar to this. If you are taking here sine function, then that is wrong. At that time you have to take displacement as cos. If you want to take velocity as sine, you have to take displacement as cos. Okay, see here. This is the a omega velocity. Velocity a omega. And here how much velocity? Yes, opposite side na. Then minus a omega. How much you have to take? Minus a omega. And time period, if you are taking the total time, this is a t. This is how much? T by 2. This is how much? T by 4. This is how much? 3t by 4. 3t by 4. For t by 4, here see here. For t by 4, how much amplitude? A amplitude. For t by 4 time period, how much amplitude? A by 4 amplitude. A by 4 amplitude. And see here what we are taking, this a by a omega plus a omega minus a omega. This is velocity time graph. Velocity time graph a omega cos omega t. If we are taking cos x cos function, then we have to take as sine function. So if we are taking that we are getting here v is equal to minus a omega sine omega t. You are getting minus a omega sine omega t. Minus represent like this. So that will represent in opposite case. That will represent in opposite case. Whatever you can take, that the resultant is same. The resultant is same. Next we'll see acceleration and time graph. Acceleration, time graph. So generally we are taking acceleration expression. A is equal to minus omega square sine omega t, because displacement what we are considering a sine omega t. So that's why you have to take, this is also in the sine function. This is also in the sine function. Now see here what we are getting the graph. So the graph is, you are getting here sine function means starts from mean position acceleration 0 and negative, and it will be goes like this. And better to take displacement graph here. Displacement graph, why? It is easy to compare. It is easy to compare. See here, this is the displacement graph. What we are considering, y is equal to a sine omega t. See here how both are opposite to each other. See here maximum, here opposite condition. Both are in opposite cases. Acceleration if you are considering, and this is a time period. This is time period. See here first mean position. It is in the positive case displacement, acceleration in the negative case. Again mean position. Extreme position means extreme position. Here acceleration positive. Here displacement negative. Both are in opposite direction. If you are taking, what is the value? Minus a omega square, and this value plus a omega square, means actually it is opposite to the direction of the displacement, plus a omega square. So like that we can able to take. So once you can see that positive graphs also means a cos omega t graph. So then what is we are getting? A cos omega t graph, this one. Displacement is a cos omega t, then velocity is minus a omega sin omega t, and that graph represents like this. Minus a omega sin omega t. And acceleration graph here cos, so that's why minus omega square cos omega t. Means compulsory, what is the graph you are taking? That must be in opposite to the direction of the displacement. Acceleration versus time, velocity versus time, and displacement versus time. And this is acceleration versus in the form of sine function. This is in the form of cos functions. Whatever we are taking, either cos or sine, we have to remember one thing: the phase difference between them. The phase difference between sine, displacement and velocity is pi by 2. Displacement and velocity, how much? Pi by 2. The phase difference between displacement and velocity is pi by 2. And you can try to draw that velocity here also. You try to draw that displacement. Y is equal to a sin omega t. What we are taking the graph? This is the graph. Velocity V is equal to a omega cos omega t. So what is the graph we are taking? This is the velocity time graph. And acceleration, what we are taking? This is the acceleration graph. We considering acceleration versus time graph. This is a is equal to minus omega square a sin omega t. So see here, what I am saying here, the phase difference between the phase difference between displacement and velocity is pi by 2. Displacement and velocity is pi by 2. What is that? Phase difference. The phase difference between displacement and velocity is pi by 2. Displacement and velocity is pi by 2. The phase difference between velocity and acceleration also pi by 2. Velocity and acceleration also pi by 2. See here how much? Pi by 2. And the phase difference between acceleration and displacement, how much? Is a pi. Very important question. The phase difference between displacement and velocity is pi by 2. The phase difference between velocity and acceleration is pi by 2. The phase difference between acceleration and displacement is pi. The acceleration and displacement is pi. This is a most important, the graphical representation. And next we will see here what about the displacement velocity acceleration displacement graphs. Okay, we'll see the graph between displacement and velocity. Displacement velocity graph. Displacement velocity graph. So I am considering displacement on y-axis, velocity on y-axis, displacement on x-axis. Before that, first you can write the relation between them. Velocity v is equal to omega into under root a square minus omega square. Then velocity v square equal to omega square a square minus omega square y square, means just squaring on both sides and send omega inside. Omega square a square minus omega square y square. Actually our requirement is relation between these two, so that's why you can send it here. Then v square plus omega square y square is equal to omega square a square. Omega square a square. So then send this omega square a square also here. Then v square upon omega square a square plus omega square y square upon omega square a square, which is equal to 1. Just you can send here or multiply and divide with omega square a square. So then that becomes as like this. Here omega square gets cancelled. Then next what we have, v square upon omega square a square plus y square upon a square is equal to 1. So actually here v is velocity, y is a displacement. V is velocity, y is a displacement. A omega square constant function, a also constant function. You can check dimensionally also equation is correct. So actually this equation is look like x square upon a plus y square upon b is equal to 1. X square upon a plus y square upon b is equal to 1 means that graph represent the equation of the ellipse. So this is a and this is b simply. If a is equal to b, then that is going to be the circle. A is equal to b, then that is going to be the circle. So see here what we have, instead of x we have v. So then take v on x-axis, and instead of y you have y only, so that's why y on y-axis. So what is you have here, b is equal to a and a is equal to, means you can take the graph, and what you are getting the graph is getting like ellipse. This value is a and this value is a omega. This is a omega and this is a. So this is the graphical representation between displacement velocity graph, most important and as well as easy displacement velocity graph. Next, let's take velocity acceleration graph or a displacement acceleration graph. You can take displacement and acceleration graph, displacement versus acceleration graph. See here. So first you can take the relation. Yes, you know that y a is equal to minus omega square y. A is equal to minus omega square y. Actually this equation is look like y is equal to minus mx plus c, but here c is 0, means axis is passing through the origin. But what is the value of omega, means what is the value of m is greater than 90, means negative means m is greater than 90. When which is 90, then what is the graph you are getting like this? What is the graph you are getting like this? This is a acceleration and this is y. Y means a displacement here, don't confuse. Y means a displacement and this is the value of m, which is greater than 90. So then this is the graph between acceleration versus displacement. Acceleration versus displacement. Acceleration versus displacement graph. Velocity versus displacement. Acceleration versus displacement. And we will see here. Next we have velocity and acceleration graph. Velocity and acceleration graph. Velocity and acceleration. So you can take velocity. First of all, you can take the relation. V is equal to omega into under root a square minus y square. Then v square is equal to omega square a square minus omega square y square. Then v square, actually our requirement is in terms of acceleration. To get that, what I am doing in this expression, I am multiplying and dividing with omega square. Multiplying and dividing with omega square. Then v square equal to omega square a square, and this is going to be minus omega power 4 y square by omega square. Omega power 4 y square upon omega square. Why? Actually a is equal to what we are writing? Minus omega square y. Then a square equal to what we can able to write? Omega power 4 y square we can able to write now. For that, just put this value here. Just substitute this value here. If you are substituting, then you can get v square equal to omega square a square minus a square upon omega square. A square upon omega square. Just you can send this value here. That becomes as v square plus a square by omega square is equal to omega square a square. Omega square a square. Just send omega square a square also here. Then v square upon omega square a square plus a square upon omega power 4 a square, which is equal to 0. Omega power 4 a square, which is equal to 0. And again this equation is look like x square upon a plus y square upon b, which is equal to 1. Again the equation of the ellipse. So then you can able to take here, I'm taking acceleration on x-axis, velocity on y-axis. So then you can get the graph like this, ellipse actually, ellipse. So what is this value? This is omega, a omega, and that is this value, omega square a. This value is omega square a. That is a and that is b. So you can take whole square. You can take whole square also, no problem. So this is the graph between velocity and as well as acceleration. Velocity, acceleration, velocity, displacement, and displacement, accelerations graph. And after that, we'll see the potential kinetic energy versus displacement graph. Kinetic energy versus displacement. Kinetic energy versus displacement. Take a displacement on x-axis. Take like this. Displacement on x-axis. So see here, you can consider it is as mean position, and kinetic energy never becomes negative. Kinetic energy never becomes negative. So what will happen here? Mean position we have maximum kinetic energy, extreme positions we have minimum kinetic energy. We know that. At mean position, kinetic energy expression what we are writing? Half m omega square a square minus y square. A square minus y square. If you put y is equal to 0, means the displacement is equal to 0. Displacement 0 on x-axis. So then we have maximum at mean position, minimum at extreme position, minimum kinetic energy at extreme positions, maximum kinetic energy at mean position, maximum kinetic energy at mean position. This is maximum and this is minimum. Next, see here potential energy displacement graph. Potential energy versus displacement. Opposite to the kinetic energy. Opposite to the kinetic energy. Potential energy, it maybe becomes negative also. Maybe becomes negative also. So then it comes like this. Mean position 0. Extreme positions maximum. These two are extreme positions. Potential energy versus displacement. Potential energy expression what we are doing? Half k x square or half m omega square x square. Wherever the displacement is 0, there that is 0. Wherever the displacement maximum, at that time the kinetic energy maximum. And you may think that this is only displacement negative positive, but potential energy positive and even kinetic energy. You can see, you can take here 0, y is equal to y, a is equal to y, then kinetic energy here 0. Here also y is equal to a, 0. So, but remaining condition, if y is equal to 0, then this is maximum. If x is 0, potential energy 0. But what about the total energy graph? If you are observing the total energy graph, you will get like this. Sorry. This is the total energy graph. The total energy remains constant. Total energy remains constant. So these are the graphical representation in simple harmonic motion. Very important. Please solve it properly.